Hello everyone, this is Venkatesh and I'll be presenting my project on capsule networks. These are the three different publications that I took for my research: dynamic routing between the capsules, matrix capsule based EM routing, and the static capsule autoencoders. So CNNs have the advantage of being very translation invariant, lower computational cost when compared to the ANNs, and it also has sparse computation. So it is very vulnerable to affine transformation, and it also loses information on pooling. Pooling will basically tell you about only the presence or absence of the part. It doesn't tell you about the spatial relationship between the parts. For example, if you have a look at the image which is present above, both the left side and the right side image are the faces, but the right side image is very much disoriented. But CNN will predict both of them as the same class. It will predict both of them are just the faces. This is wrong, right? So it also needs excessive amount of data augmentation in order to solve this and also to achieve some good amount of decent results. So to solve this, we have something called capsule networks, and we have implemented the paper called dynamic routing between the capsules. It negates the disadvantages of CNNs caused by affine transformation and pooling. It replaces the CNN's feature detectors with vector capsules, and pooling is replaced by routing by agreement. So the instantiation parameters, which are nothing but the orientation, the pose and stuff, are being represented by means of vector called capsules. So routing by agreement is nothing but coupling a low level layer with a higher level layer. So coupling my nose with my face. Nose is my lower level feature and face is my higher level feature. That is what is being represented in the bottommost right side of the image. So you have a nose vector which is being sent into computations, and it is like related to a higher layer which is higher feature, which is nothing but the face, which is represented by UJ. So it is coupled by means of a coupling coefficient. So it works pretty well on smaller data sets without the need of any kind of data augmentation. This is the architecture of dynamic routing between the capsules. So you have the encoder and the decoder part. The encoder part will be able to have a convolutional layer which will extract the basic features from the image and then send the weighted combination of features to the primary capsule, which will in turn send the computation to the digit capsules, or also known as the secondary capsules. So primary capsule will retrieve the low level feature and the digit capsules will be able to retrieve the high level feature. This is in turn sent into a decoder, which will be used for reconstructing the image, which is very close to the original image. So you can also have a look at the squashing function at the bottommost left part of the image. So you can have a look at the unit scaling, which will normalize the values between 0 to 1. And you have an additional squashing layer in order to make sure that the values which are somewhat close to 1 become very close to 1, and the values which are somewhat near 0 become exactly like very negligible and close to 0. You have the loss function of the capsules computed by using the following formula, which is also known as margin loss. For the correct predictions, you will be having the left part of the equation calculated for loss. And for incorrect predictions, you will have the rightmost part of the equation being computed. So you can have a look at the outputs that we have generated. So the input and the output shapes can be looked at this tabulation, and you can have a look at the loss plots for MNIST and Cypherton dataset. So it is monotonically decreasing, and we have the test accuracies for MNIST and Cypherton of non-affine and affine transformed datasets. CNNs are not so robust for affine transformations, whereas capsule nets are very robust. And based on the literature, we see that the accuracies that we have obtained for affine transformation based capsule network classification is much better when compared to the CNN classification. So you also have a look at the reconstructed images of MNIST and Cypherton. Though it is slightly blurry, MNIST is reproducing exact images and Cypherton is not so good in reconstruction. This is the next project that I've implemented based on this particular concept, which is basically the first attempt in the literature to use capsule networks for activity tracking. We monitor around 6 activities like walking, jogging, sitting, standing, moving upwards, and moving downwards. So this is done by using 3-axis accelerometer values, and the data is segmented into several segments of 90 samples each. So we have a test accuracy of around 85%, which is obtained after a trained test split of 80% and 20% respectively. So you can have a look at the loss plots of the data set. And this is the confusion matrix. The confusion matrix will show you how dominant the particular classes are. And you can see that the diagonal elements symbolize the dominance of each and every classes. So on concluding my project, I would like to say that CNNs are still the most preferred algorithms when compared to the capsule networks. But I really feel that immense research and better optimization of the capsule networks will definitely make sure that one day or the other, we will be using capsule networks instead of CNNs. My work is basically depicting that capsule networks can be used for both spatial information extraction and temporal information extraction. So for more details, you can have a look at the GitHub repository that I've attached over here. Thank you so much for this opportunity. Thank you one and all. Have a good day.